Good morning, students. So let us start solving examples which are based on sum and product rule and the theorem which I have solved in previous section. Fine. So let's start with example number 1. So in how many ways, six men and six women are seated in a row A. If any person may sit next to any other. Fine. Whereas in B, if men and women occupies alternate seats. And this is what question. There are six men and six women, and they are seated in a row. ಆರು ಹೆಣ್ಣು ಮತ್ತು ಆರು ಗಂಡಿದ್ದಾರೆ. ಒಂದು ಲೈನ್ ಕುಂದಿರಿಸಬೇಕು. ಯಾವ ತರ ಕುಂದಿರಿಸಬಹುದು ಅಂತಂದ್ರೆ ಎನಿ ಪರ್ಸನ್ ಕ್ಯಾನ್ ಸಿಟ್ ನೆಕ್ಸ್ಟ್ ಟು ಎನಿ ಅದರ್. ಯಾರಾದರೂ ಯಾರ ಬಾಜುಗೆ ಬಂದು ಕೂಡ್ಬೋದು, ಬಟ್ ಒಂದೇ ರೋ ಅಲ್ಲಿ ಕೂಡಬೇಕು. ಎರಡನೇದು ಹೆಂಗೈತಿ, ಒನ್ ಮೆನ್ ಆ್ಯಂಡ್ ಒನ್ ವಿಮೆನ್, ಒನ್ ವಿಮೆನ್ ಆ್ಯಂಡ್ ಮೆನ್, ಈ ಥರ ಒಂದೇ ರೋ ಅಲ್ಲಿ ಕೂಡಬೇಕು. ದಟ್ ಇಸ್ ಇಫ್ ಮೆನ್ ಆ್ಯಂಡ್ ವಿಮೆನ್ ಆಕ್ಯುಪೈಸ್ ಅಲ್ಟರ್ನೇಟ್ ಸೀಟ್ಸ್, ಅಂದರೆ ಒಂದು ಗಂಡು ಮತ್ತು ಒಂದು ಹೆಣ್ಣು ಮತ್ತು ಒಂದು ಗಂಡು ಮತ್ತೊಂದು ಹೆಣ್ಣು, ಈ ಥರ ಅಲ್ಟರ್ನೇಟ್ ಸೀಟಲ್ಲಿ ಕೂತ್ಕೋಬೇಕು. How the sitting arrangements can be made. Fine. Solution. If any person, first one, if any person may sit next to any other, then there is no distinction or distinguish. So why I am using word distinguish here? Because they are distinct. I mean to say they are separate. So there is no distinction or distinguish made between men and women. So anybody can sit next to any other person. That means there is no distinction between men and women. Fine. In their sitting arrangements. Since there are total of 12 persons. How many persons are there? 6 men and 6 women. Total it becomes 12 persons. That is what we write in the bracket. 6 men and 6 women. The number of ways they can be seated they can be seated in a row is what? That is 12 factorial, that is 12 into 11 into 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. That is 12 factorial is equal to 479 00 1600. So this is what arrangements with respect to if any person can sit to any other persons next to the any other person. This is what arrangements. Next comes V. What is V here? If men and women occupies alternate seats. So what happens? Then 6 men can be seated in 6 factorial ways in odd places. So in odd place first men are sitting, then women, then men, then women, means what? The place of the men sitting is totally odd, that is 1, 3, 5, 7, 9, 11, 13, 15, 17, like this. Means men are sitting in odd places. Fine. And 6 women can be seated in 6 factorial ways in even places. That is, women are sitting in a position 2, 4, 6, 8, 10, 12, 14, 16, like that. Means women are sitting in even places. Therefore, the number of ways in which men can occupy the odd places and women can occupy even places. That is 6 factorial into 6 factorial, that is equal to 720 into 720, that is equal to 5,18,400 ways are there, provided men are sitting in odd places and women are sitting in even places. But what happens if we do the reverse? Like women are sitting in, that is similarly the number of ways in which men can occupy even places and women can occupy odd places. Then what happens? Then again it is 6 factorial into 6 factorial. This is 720 into 720 followed by, again it is 5,18,400 ways. Then total number of sitting ways are. So why we are making total here? Because at first it is what? Men's are in odd place and women's are in even place. But in next, women's are in odd place and men's are in even place. Fine. So that is what vice versa of odd and even place for the men and women. So both we need to calculate here. So R, that is 5,18,400 plus 5,18,400. Fine. Then the total is 10,36,800 sitting arrangements can be made if men and women occupies the alternate seats. Right? This is the most common question is asked in the examination. Maybe they may say instead of 6 they may say 8 and 8, or they may say 6 and 8 or 8 and 6. The number is changed, but the methodology never changes. So I urge the students to kindly copy this. Fine. So these are the most common questions appears in examination. Fine. Thank you, students.